Okay, so 10.4, this is where I'm going to introduce logarithms and then teach you a lot more about them for the rest of the chapter. It's going to be great. Okay, so the definition of these things, it's basically that they're really related to the exponential functions. Okay, so we're going to define these as a relation to the exponential functions that we've worked with in the past couple sections and go on from there. So logarithmic function, it's the inverse of an exponential function. Okay, so we've worked with exponential functions before. Okay, so y equals b to the x power, right? That's an exponential function. X. Okay, that's an exponential function. Now the inverse of that means that you basically swap out the x and the y's. They switch positions. Okay, so if you do that, all right, if you want to find the inverse of a function, that's what you do. So we've got x equals b to the y power. Okay, but then what we want to do is we never write equations like this with x equals something. We always want y equals something. But there's no way to solve for y here that we know of. Okay, there's no way to solve for y here. So because of that, okay, this is where a logarithmic function comes in. All right, because of that, there's this function, a logarithmic function, that allows us to turn this into something that has y equals something. Right, and what it looks like is to be y equals the log base b of x. Okay, and obviously I'll explain a lot more about what that's like, but that's what that's going to look like. Now, the base cannot be 1 for a logarithmic function. Right, so y equals log base b of x. This base right here, right there, can never be 1. Right, now think about why that might be the case for something like this, and we'll discuss it in class. Okay, so the definition of an actual logarithm. Okay, this is the best way to remember it. Right, so log base b of n equals k if and only if, right, you learn this term in geometry, if and only if, b to the k equals n. Okay, it's b to the kth power. So, kind of the best way that I think of this is I think of log of the base, log of base of the answer equals the exponent. Okay? Now, that might look weird, but if you think of it this way, b is the base, so this base is both the base of the logarithm and the base of our exponential function, right? Because these are always relating to exponential functions. That's why I think of it that way, because I don't know much about logarithmic functions, but I can definitely solve exponential functions. Okay, so the base is that b, base of the log is also the base of the exponential, right? Of the answer, so the n is the answer to our exponential function. Right, see how n is the answer to the exponential function, equals the exponent of our exponential function. Right, so see how k here is the exponent of the exponential function. I totally understand if you have no clue what I'm talking about right now. It makes sense. I get it. Right, it's totally new. But if you think of it this way, log of the base of the answer equals the exponent. It'll help you translate the logarithmic functions that we don't know much about into an exponential function that we are more inclined to solve. Okay, so I'll illustrate this. Obviously, there's a lot of examples, but I'm going to go through these special log problems first. Right, and just to help us see how to translate these into something we can work with. All right, so if you had log base b of b to the k equal, it's always going to be equal to whatever that k is. And let me explain why. If you think of this, all right, I'm always going to translate into an exponential function because I don't want to deal with log functions. All right, so if I turn this into this, I've got log base b, so the base of my exponential is b, of the answer, so that's the answer, b to the k, equals the exponent. B to the k equals b to the k. That makes sense. That's why that always works. Okay? That's going to be in my way. Okay. Second one, the exponent. All right, this is an exponential function. If you ever have b to the log base b of n, the answer is always going to be n. And I'll show you how that works. All right? If you just convert these, if you just manipulate them, change them in and out from logarithmic to exponential and from exponential to logarithmic, usually something works out. So I'm going to convert this one to a logarithmic function. All right, so log base b of the answer to my exponential to the n equals my exponent, which happens to also be log base b to the n. You probably think it looks like I'm not doing anything right now, and that's kind of true. All right, this is just to help us begin to convert these to and from exponentials and logarithmic functions. All right, now the last two are kind of helpful, actually. You'll actually see these appear a lot, all right, and these are really easy problems. You might even see them on the SAT and ACT. All right, so if log base b of b, all right, if their base and the answer are the same thing, then the answer to this is always going to be 1. And I'll show you why. Because we convert this to an exponential, so the base is b, the next number is the answer, equals the exponent. So 1 is my exponent. B to the first is b. So the log base b of itself is always, always, always 1. And the last problem here, right? It doesn't matter what your base is. If you have log to some base of 1, the answer is always going to be 0. And I'll show you why. Convert it to an exponential, base of answer equals exponent. Anything to the 0 power equals 1. Right? Doesn't matter what it is, anything to the 0 power equals 1. So if your 1 is over here in a logarithmic function, the answer is always going to be 0. Okay? Let's get into some with numbers. Hopefully it'll be a little bit more clear from this stuff. All right? A couple more just conversions. All right, so we'll start with, we're going to convert this logarithmic function to exponential form. So remember, base of answer equals exponent. 3 to the 4th equals 81. Okay, we know that's actually true. All right, we're going to now convert the exponential to the logarithmic. All right, so log of the base of the exponential of the answer equals the exponent. Okay, and we'll do more practice on those conversions with the problem. Okay, so now we're going to simplify these things. All right, I always am going to write them as an equation, right? Because I find that to be helpful. So set it equal to x. Okay, convert it to an exponential. So 2 to the x. Actually, I probably need some more space here. 2 to the x power, because base, exponent, answer equals 0.125. Well, 0.125 isn't very helpful to us, so I'm going to rewrite that as 1/8. All right, and now this looks like a problem that we learned back in section 1. Okay, so we need to convert these. So in order to solve for x, we need to get the same base. So 2 to the x is going to stay the same. I need to rewrite 1/8 with base 2. So it's 2 to the negative 3 power. 2 to the negative 3rd power is 1/8. So that means that x equals negative 3. Okay? Number 2. Set it equal to x. Write it as an exponential. Base, exponent, answer. Okay? 1/3 to the x power. Oops. Equals the 4th root of 3. I'm just going to write it as 3 to the 1/4. Okay? So what I would do is I would convert one of these two to, they gotta have the same base, can't have 1/3 and 3. So if I change 1/3 to 3 to the negative 1, I've got 3 to the negative x equals 3 to the 1/4. Okay, so negative x equals 1/4, and x equals negative 1/4. Okay, number 5. All right, set it equal to x, base, exponent, answer. Convert it. 2 to the x power equals 4 root 2. Okay, well 4 root 2, that's not very helpful to us. I'm going to rewrite this. It's the same as 4 root 2 is the same as root 32. So I'm going to write root 32 as an exponential. So 32 to the 1/2 power. All right, so I need to get the same base. 2 to the x equals, well 32 is the same as 2 to the 5th to the 1/2. Okay, so x equals 5 times 1/2. X equals 5 halves. Okay, and lastly, little tricky one, just keep you on your toes. Set it equal to x, base, exponent, answer. Convert it. 7 to the x equals 1. Anything to the 0 power is equal to 1, so x has to equal 0. Okay. And the last couple problems are actually equations, so you're not always solving for the exponent. Okay, number 7, this is just like a problem we've done, right? We've got to convert it. Base, exponent, answer. 4 to the x equals 2. Okay, we need to rewrite these with the same base. I'm going to change the left side to 2 to the 2x power, right? Because 2 squared times to the x power equals 2 to the first power. So 2x equals 1 and x equals 1/2. Okay, you could also look at this right away and say, oh, well, 4 to the 1/2 power, the square root of 4 is 2. That's obviously fine. All right, number 8, I've got to convert it. So base, exponent, answer. Convert it. Base, the exponent equals 5. Okay, so I've got basically 1 over x equals 5. Multiply both sides by x, divide by 5, or just realize that 1/5 is what we're looking for, right? We're looking for the reciprocal of 5, so x equals 1/5. Not a very good 5. Okay, and the last one we're going to do here is log base 9 of x equals 3/2, so convert that. Base, exponent, equals answer. Okay, so I'm going to just turn this into an exponential, or turn it into a radical. So I've got square root of 9 cubed equals x. Well, I could do the square root of 9 first, and rewrite this as 3 cubed equals x, and that we know is 27. So that's pretty much it for 10.4. That's basics of logs.